orchestrated dance giving you results. This is exactly how in real life scenarios you can start using mathematics, you can start using numbers and get to an understanding of what is happening. Great. Now let's continue the story. What happened one fine day was his friend came to him, one of the friends that he used to bully, and said, "Friend, I'm in a lot of trouble. Can you please help me with 40 gold coins? I have something that I have to immediately take care of, and in couple of days I will actually return these gold coins to you," is what his friend said. So Ted had become generous by now that he was actually spending and he had all of this money. He said, "Yes, I will give you those 40 gold coins. Don't worry." And he ended up giving him another 40 gold coins. He loaned those 40 gold coins to his friend. So he was at 50 gold coins. He loaned 40 gold coins to his friend, and now he is at 10 gold coins. And his friend was an honest person. Just like what he had told him, he came back and he returned his 40 gold coins. So he had 10 gold coins. Now he returned 40 gold coins, and the total number of gold coins that is left with Ted is a value of 50 gold coins. Did you observe in the previous case that 50 had become 10 and I had moved the gold meter in this direction? Now 10 has actually gone to 50 and I've moved the gold meter in the opposite direction. Just observe the way in which I'm moving the gold meter. Very, very important as far as maths is concerned. But you know the numbers already, right? All of you are smart, and I'm pretty sure you know the numbers of how I'm basically getting to. So this strategy of his, that is his lifestyle that he had basically gotten into when he was actually spending a lot of money, that continued. He did not stop that particular lifestyle. So it reached a state where he had no more money left because he kept spending. He did not earn anything. He kept spending, and it reached a state where he had no more money left. Now, if I were to basically say that he has no money left, that is how I will communicate it in English. Is there a way in math that I can communicate it? How do I communicate or represent nothing? How can I basically think about a math number? I can say that this is one pen because this one pen is there. Now, if this pen is not there, how do I communicate this? You know what? There was this person who you see on the screen. His name is Aryabhatta. He invented this idea of communicating nothing. And the idea was that I will represent something like this. I will write a neat little O or a neat little circle out there, and I will call that 0. And that is what he basically said. If I were to represent nothing, I will represent it by this particular number called 0. So now, getting back to the story, when Ted had no money left with him, if you were to ask me mathematically how much money he has with him, I will say that he has got 0 amount of money. Now again, his lifestyle did not change. He continued to spend that money. Now, when he continues to spend that money, when he does not have money, how do you think you can do something like that? You have to borrow money, right? You have to borrow money, which effectively means he owned money before, which is the 100 gold coins that he had. He no longer has these 100 gold coins because he spent it all away. Now, if he has to continue to spend, what he has to do is to borrow money from somebody. So he went to some landlords and he said, "You know what, I will pay back this money," because he was a nice, good liar, right? He made up some stories. He communicated a lot of things to these landlords, and he basically started borrowing money. The first time he went and borrowed money, see, now Ted basically had a lot of money. He owned money. He went to a state where he had no money, that is, he had 0 money, and now he started borrowing money. Now do you see how Ted is? He's gotten back to his old shabby clothes. Sorry, Ted, you shouldn't be doing this. This is a bad habit. You should not spend more than what you basically have. Never do that, right? So now he started borrowing money. The first thing that he basically did was to borrow about 10 gold coins for a food and party that he had arranged for himself and his friends. So he borrowed 10 gold coins. He used these 10 gold coins and he gave a party to his friends. So now, what is the total amount of money that he owed to that landlord? He actually owed 10 gold coins, right? He owned 10 gold coins or 100 gold coins in the previous state. Now he owes 10 gold coin to his landlord because he had borrowed that particular money. Now, his lifestyle did not change. So, over the next 2 months, he kept borrowing money from a lot of different people. And over time, he actually borrowed another 60 gold coins to maintain his lifestyle. His lifestyle of not earning but spending. That lifestyle, to maintain that lifestyle, he borrowed another 60 gold coins. So, he had initially borrowed 10 gold coins. Now, he borrowed another 60 gold coins to have totally borrowed 70 gold coins. Now, in terms of how much gold coins or how many gold coins does he owe? He owes 70 gold coins. Initially, he owned 100 gold coins and now he owes 70 gold coins, right? Very, very, very bad lifestyle. Then one fine day, it occurred to him that he had a lot of fancy ornaments with him. He had actually bought fancy ornaments by spending 40 gold coins, right? So he had those ornaments with him. He could go and sell those ornaments. And when he did go and sell those ornaments, because they were used ornaments, the goldsmith actually ended up giving him 20 gold coins. He said, "You can give me all these ornaments. I will buy it at 20 gold coins." So Ted actually sold these gold coins or all of these fancy ornaments at a value of $20 gold coins. So now when he sold, he went and promptly returned this money to the landlords. So he had owed 70 gold coins, right? That is what he had owed before. So now he returned 20 gold coins and he ended up owing 50 gold coins, right? What I wanted you to notice was the way in which the gold meter basically moved. Whenever he spent money, he basically gave away money, it ended up going in this particular direction. Whenever he basically had or got back money, it started going in this direction. That is what I basically wanted you to observe. But the math of it is very, very simple. So now the question comes in as how do I represent something that he owns and how do I represent something that he owes? Can I represent it by the same number? What I did in all of this was he sold his fancy ornaments and he got a value of 20. That is something that he got because he owned that particular fancy ornaments and he exchanged it for gold coins. He owned that. But he borrowed 60, he had borrowed 60 gold coins to maintain his lifestyle. When he owns something and when he borrows something or he owes something, how do I represent this in mathematics? Think about them as opposites of each other, right? Whatever he owns, let's say he owns 50 gold coins and he owes 50 gold coins. That is, he has 50 gold coins and he can count these 50 gold coins that he has with him. So now he goes to a state where he has 0 gold coins and then he starts borrowing this money. Now, when he borrows this particular amount of money, he no longer owns this money. It is somebody else's money. Eventually, he has to return this money back to the person from whom he borrowed this money from, right? So, he owes this money. Can I represent both of these scenarios where he owns and where he owes by the same number? Or do I have a different way of representing this entire thing? Or can I think about it as 50 gold coins is what he owns and whatever he owes is 50 gold coins, which is an opposite of the 50 gold coins that he owns. So whatever he owes, that is whatever he has borrowed, can I basically call it as opposite of 50 that he owned? Opposite of what he owned is what I basically have borrowed. Just follow with the idea that I'm basically trying to communicate. How do I communicate opposite of a particular number in mathematics? That's the question that I want to basically answer, right? There is something that I owned, that is something that belongs to me, and now I have borrowed this money. I have 4 gold coins with me, which is something that I have of my own, and now I have borrowed 4 gold coins. So now how do I communicate that I have borrowed 4 gold coins using mathematics. It turns out that both of these are opposites of each other, and to communicate the opposite of the number that I own, I use this particular symbol and I write the value of that particular symbol. So if I were to communicate it, I will write a negative sign and I will write the value. And these numbers are called negative numbers, right? Negative numbers are also numbers. They also have a value, but they have a negative value. What do I mean by a negative value? Basically, there are positive numbers. There are these numbers which I can count because they are actual numbers that are there. And now there are numbers which are not there. They are an idea. They are an opposite of this particular positive number. And those numbers is what I basically call as negative numbers. So now negative numbers and positive numbers actually give you a sense of direction. What do I mean by that? If I were to basically plot all of this on a number line, if this is my number line, and I say the state where he did not have any money, that was before he met the magician or after he had spent all the money, that if I call that state as 0, all the numbers that I can basically write on this particular line to the right of this particular 0 is what I call as positive numbers. And every other number that I can write to the left of this particular number line is what I call as negative numbers, right? And a number line, like you already know, need not necessarily be vertical. It can need not necessarily be horizontal. It can also be vertical. So all the numbers that are below this particular number 0 is what I call as negative numbers. And all the numbers that are above this particular number line, above 0 on this number line is what I basically call as positive numbers, right? So now you know that from a notation of where these numbers exist on the number line, you know that anything that is to the left of 0 is what you basically call as negative numbers. So what is a negative number? It is basically opposite of a positive number. That is how you can take a look at it. You can think about it as a mirror. There is a real object that is there. There is a mirror. The mirror happens to be 0, and the reflection of this real object that is there is what you basically see inside the mirror or behind the mirror. So what have we learned till now? There is a mirror, there is a reference value, there is a 0 which basically acts as my reference value, and there are numbers which are on one side, that is to the right side of 0 as far as the number line is concerned. We call them positive numbers, and there are numbers to the left side of 0 which is what we call as negative numbers. So now if I were to take all of these numbers, that is positive numbers, 0 and negative numbers, if I were to club them all together, do I have a name for it? Turns out that there is a name for it. For now, I will basically call them as new numbers, but turns out that this entire set of numbers has a name, and we will get to that. But what I want you to take away are that these new numbers that we have basically spoken about till now has 2 characteristics to them. One characteristic is that it has a value, it has a quantity associated with it, and it also has a sign associated with it as far as the numbers are concerned. So there is a plus 4 and a minus 4. So let me write this out. A plus 4. There is a plus 4 and a minus 4. And it turns out that you don't necessarily need to write this plus 4. All positive numbers that are there, right? You can just write it as 4. And everybody in the world of mathematics, in the world of mathematicians understand this language. The plus 4 or the positive numbers are the default numbers. Everybody understands when you write a 4, you're actually trying to communicate that it is a plus 4. It is a positive 4. That is what you are trying to communicate. But when it comes to negative numbers, when it comes to numbers that are on the left side of the 0, you always have to write that particular symbol. That symbol of minus is something that you'll have to write. And you have to communicate it as negative 4. Very, very important, right? a lot of times you basically start talking about it, and you will start saying -4. That even I would have basically done that in some of these conversations. But in the world of mathematics, it is best to communicate these as negative numbers. There's nothing called a -4. Minus as such is an operator. You use that as plus, minus, multiplication and division. These are operators, whereas numbers are concerned, there are positive numbers and there are negative numbers, right? So what is the takeaway? The new number has got two characteristics. There is a sign associated with it. There's a positive sign and a negative sign, which creates positive numbers and negative numbers, and there is a value or a quantity associated with it. So now, where else do we actually use negative numbers, if you ask me? We use negative numbers in a lot of places. I'm pretty sure you've heard of temperatures in places going to sub-zero level, right? Even if you go to this place, let's say you go to Srinagar during winters, which is in Jammu and Kashmir, if you go there, temperatures drop to a below 0 degrees Celsius. That effectively means temperatures are -3, -4 in Srinagar at times. When I'm talking about this place from where I'm trying to help you understand this particular concept, that's Bangalore. The temperature today is about 25 degrees Celsius. It is a positive 25 degrees Celsius. 0 degrees Celsius is taken as my reference point. Anything that is hotter than 0, I call it as positive temperature. Anything that is colder than 0 degrees Celsius is what I call as negative temperature, right? So in the same way, I can talk about heights and distances of places, and I can always put a reference point. When I'm talking about heights of a mountain, right, the reference point that we put is the sea level. When you are at a beach, where you are as far as the height is concerned is at a 0 height, right? That is the sea level is the 0 that we basically have, and that's your reference point. Anything that is higher than 0, or anything that is higher than the sea level, or anything that is higher than the beach where you are standing at is called positive or higher, or they are a mountain, and anything that is below the sea level is what you call as negative numbers. So now, if I were to represent this entire scenario that is out there, what you see out there is Kanchenjunga. What is Kanchenjunga? Is that the highest peak in India, or is Mount Everest the highest peak in India? Are you saying Mount Everest? I'm pretty sure you did not say that. I wrongly heard it. Mount Everest is in Nepal. Kanchenjunga is the highest peak in India, right? And if you were to talk about the height of Kanchenjunga, it is 28,169 feet above sea level. Sea level, reference level. From the reference level, it is 28,169 feet. Now, if there is a place that is below sea level, and it turns out that Kuttanadu in Kerala is below sea level, and if you were to communicate this, that it is below sea level, how you will communicate it is by writing that minus sign behind that number. When you write -8, when you pronounce it as a -8, you basically are saying that this place is below the reference point that we had basically taken into account, and Kuttanadu is one of such places. So now you know that you are able to use negative numbers to represent heights. Now you know that you're able to use negative numbers to actually represent temperature as well. Are these the only places that you can use negative numbers? I'm pretty sure you've already seen lifts where they have written a -2, a -3. What are they basically trying to say? If there is a ground level, that is the ground at which maybe a reception is there, and anything that goes above that ground level, that is floors above ground, you can basically write it as a 10. Technically, if you want to write it, you'll have to write it as a +10. But like I told you, plus is a default operator, so you don't necessarily need to write a plus. And if you were to say something is below a particular ground level, you can represent it as a -2. That is how you represent it as a -2. Are these the only places that you use negative numbers? Turns out, no, you use negative numbers in a lot more places. You use negative numbers when you're actually even doing business. If you were to buy a particular an item, right? You may buy it at, say, 10 rupees and you sell it at 12 rupees. That is when you make a profit. This extra 2 rupees that you got, if 10 rupees were to be my base, I got extra 2 rupees, that is higher than my base that I spent, and that is when I say it is profit. And if you were to actually sell it at, let's say, 8 rupees, you bought it at 10 rupees and sold it at 8 rupees, My base was 10. I sold it lower than my base, and therefore I call it the negative number. So now, if I made a profit of 300 rupees, how will I communicate it? I will write a 300. Now, in the same way, if I made a loss of 300 rupees, how will I communicate it? I will communicate it as negative 300, or that minus symbol, that dash that is there is very, very important to communicate all of it. So what have we learned till now? There are new numbers which have got two characteristics. There is a sign associated with it, a positive sign and a negative sign, and there is a quantity or a value associated with these new numbers. So there are positive numbers and there are negative numbers, and it gives you a sense of direction. This plus and the minus actually gives you a sense of direction, and 0 is your reference point. So now when somebody says I owe something, it effectively means, in terms of mathematics, you're supposed to start thinking about the negative side of 0, or the left side of the number line. When somebody says I own something, you start thinking about it on the positive side or the right side. When somebody says I go down from my reference point, it is the negative side. Somebody says I go up from my reference point, it is the positive side. When somebody says I go left of my reference point, it is the negative side, and if somebody says I go right of my reference point, it is the positive side. What I want you to take away is how are you going to start understanding this? How are you going to start visualizing negative numbers, and where do they actually live on the number line is something that I want you to basically start thinking about. And what are negative numbers? I already told you. Negative numbers are opposite of positive numbers. Just think about them as opposite of positive numbers, because it will help you a long way when you're actually trying to understand the world around you. So now when somebody tells you that they owe 30 coins, that is, they have borrowed 30 coins that needs to be returned back, how would you write it? You would write it by a negative 30. And if you owned it, that is, the coins belong to you, you basically represent it by a 30. You don't need to write the plus sign, because plus is the default operator, or plus is the default way in which you communicate numbers, because these are natural ways of communicating numbers. So now if somebody tells you a minus 10 meters below sea level, that is 10 meters below sea level, how would you write it? You will write it as a negative 10. You will write that minus 10, minus symbol there, and then you will write the value. I told you, all of these new numbers have both a value as well as a sign, and the sign happens to be minus out here. And when somebody tells you 25 meters above sea level, you will just write it as 25. By default, behind the scenes, it is a plus 25, but this plus need not necessarily be written, because plus or positive numbers are your default numbers. Minus 25, when they basically talk about to the west, and 10 meters to the east, you will basically write it as plus. So now if this is to your left and this is to your right, you'll basically say whatever is in the left is minus, and whatever is plus, whatever is to the east is plus, right? That is something that you will basically have. So now this minus sign that you basically saw represent opposite of things that you have. So now let's go in deeper and talk about a few more numbers. 25 degrees Celsius temperature below 0. How do you represent it? Minus 25 degrees Celsius. Why minus? Below 0. 180 meters above sea level. Above, you basically write it as 180 meters. You don't necessarily need to write the plus sign, because plus is the natural numbers, or the positive numbers are your natural ways in which you can basically write it. A profit of 125 rupees, you will write it as 125, no need of plus. And a debt or a loss, or I owe 30,000 rupees, you will basically write it as a minus 30,000 is how you will basically communicate it. So now you've got the idea of when do you have to use the plus sign for the new numbers that we have spoken about, and when do you have to use the minus sign for the new numbers that we have spoken about. So now let's move on and understand a few more things as far as these numbers are concerned. Okay, now let's talk about the number family. What? Numbers? Do they have families? Well, it turns out they do have families, right? What do I mean by number families? Well, let's say I take some 4 or 5 cats together out here, and I group them together, I can call them a cat family. Why? Because even though each of these cats are individual cats, they have their own characteristics, but they also have certain common characteristics. They also have certain common traits, right? That is why you can call them the cat family. I also told you that math is a language, right? Now, if I were to compare and contrast that with English, the language that you know, if I were to take the alphabets or letters A, E, I, O, U, can I group them together? A, E, I, O, U, can I group them together and can I call it by a special name? I can call that a vowel family, right? Why? Because all of these 5 letters that I'm talking about have certain things which are common among them. So when I have certain things which are common, I can group them together, logically put them all together, and I can call that a family. In the same way, if there are numbers that have certain common characteristics that I can logically group them together, I have certain number families that I end up with, and each of those number families I start giving a special name, right? If there are numbers which I can count, I call them counting numbers or natural numbers, something that you've already seen. So now before I get there, I just want you to appreciate one more thing, right? When I took the example or the story of Ted, there was a reason why I took that. When I wanted to first communicate to you what negative numbers meant, and now you understand what negative numbers meant. When he started borrowing money, that is when you started or got introduced to this logic of negative numbers. Why is negative numbers a logic and not something that you could basically use? Now, if I say I have 4 fingers, very easy to say I have 1, 2, 3, 4 fingers, and I can see these 4 fingers, right? This is very natural for me to basically see. The worst that I could do is close all my fingers and I can say I have 0 fingers that I've opened up. But now if I were to say that I have minus 4 fingers or negative 4 fingers, what does it mean? Does it mean anything at all in the physical world? It turns out that in some places it means certain things in the physical world, in other places it does not. Therefore, it is a notion, it is a logic that we have to basically understand. So now you've understood the notion or the logic of what negative numbers are. So I'd used this particular example to also help you understand the different family of numbers that it can basically belong to, right? The numbers where you can start counting, like he counted gold and gave it away to buy his royal clothes and so on. Those numbers, when you group them together, you can call that the natural number family. So now you take the 0, that is when he had spent all the money that he had or all the gold coins that he had. You take then he ended up with a 0. You take the 0 and add it to the natural number family. The family that you end up with is what you basically call as whole numbers, something that you've already understood and learned in your previous grades as well. So now when you actually take the negative numbers and put them together with the whole number family, what you end up is what we call as the integers, right? The new numbers that I was talking to you about some time ago, that when you have an actual name in mathematics, that name is what we call as integers. So what is integers? If I were to become a professor and I were to come to you and talk to you about integers, integers is nothing but negative numbers, 0, and positive numbers, or negative numbers and whole numbers put together into one family, and that family, that name of that family is what we call as integers, and that is actually the name of the chapter as well. Great. Now, where do integers live? You know, all numbers live in the number line, something that we have already discussed. So now there are special ways in which we have actually arranged these numbers on the number line as far as integers are concerned. You already know that 1 lives somewhere over here on the number line, 2 lives here, 3 lives here, 4 lives here. All these positive numbers, all these natural numbers tend to live on the right side of the number line, whereas all the negative numbers, that is negative 1, negative 2, negative 3, negative 4, actually live on the left side of the number line. That is one observation that I basically want you to make, where the reference number or your middle number is going to be a 0. So now you know where they live on the number line. Is there a special way in which we have arranged this? We will get to that particular thing as we move along, right? And in the story, I'd asked you to observe the gold meter as well. So now let's observe what happens to the value of that number when you basically move on the number line, right? Just imagine the gold meter to be the number line itself and see what is happening as far as the value of the number is concerned. Is the value increasing? Is the value decreasing? Is something that I want you to answer as we go through a couple of these things that happened in the story. So when Ted got more money, which direction did the gold meter move in? Did it move to the right or did it move to the left? He had, let's say, 40 gold coins and he now ended up getting 70 gold coins. Now he's got 30 extra coins. So when he got 30 extra coins, it moved to the right, right? Very, very good. So now, initially, if he had owed 70 gold coins, now he somehow magically earns or he sells off his gold ornaments and he gets another he gets some gold coins and now he is at a negative 40. That is, he's got about 30 gold coins and he's returned it. Where is the value greater? Very, very important. I understand minus 70 and minus 40, but which one is greater? Now, to answer that, which one is greater, which is a better scenario for you to be in? To owe 70 gold coins to somebody or to owe 40 gold coins? Owing 40 gold coins is better, right? Which effectively means you're in a better state or a more positive state than the 70 gold coins that you basically owe. Which effectively means as we move right on the number line, right? As we basically move right on this number line, what ends up is the value starts to increase. The value of the numbers that you're basically having, as you move right, it starts to increase. So now, continuing on the same logic, if I were to basically move left on the number line, 1 minute, let me choose the right color. If I were to start moving left on the number line, that is, if I were to start moving in this particular direction, what happens to the value? Something that we will anyway take a look at right now. So now he had 100 gold coins. He spent and he ended up with 50 gold coins. Now he has lesser, which effectively means as you keep moving left, the value has to decrease, right? The same way, he had borrowed 10 initially, 10 gold coins, and therefore I brought it to the negative 10. Now he borrows another 30 and it becomes a negative 40. When something like this basically happens, he's borrowed more, therefore he has lesser amount of money with him. That's the way in which you've got to basically think of it. So in essence, if I were to go right, if I were to move right on the number line, yeah, I will effectively keep increasing, and if I were to go left on the number line, I will effectively keep decreasing in value. Very, very important observation that I wanted you to basically make. So with that observation comes a couple of scenarios, right? Is 4 greater than 3? Of course. Why? Because having 4 fingers is better than having 3 fingers, or greater than having 3 fingers, right? Therefore 4 is greater than 3. Now, in the same way, is minus 4 greater than minus 3? Turns out that no, it is not. Minus 4 is lesser than minus 3. Multiple ways of thinking about it. As we move to the right on the number line, the value is supposed to increase. That effectively means minus 3 is to the right of minus 4. Therefore, minus 3 is greater than minus 4. One way to observe it. Or how much, which is a better scenario for you to basically be in, right? Now, if I were to talk about Ted and the scenarios that he was in. If scenario A or Ted A owed 4 coins and Ted B owed 3 coins, who owes more? Of course, Ted A owes more, right? And therefore, Ted A has lesser in value, and therefore you can say that minus 4 is lesser than minus 3. That is something that you could basically say. When it comes to the positive side, very, very simple. If Ted C owns 4 coins and Ted D owns 3 coins, who has more coins? The Ted C who has 4 coins is more, and therefore Ted C is better than Ted D. What am I trying to establish? Move right, increase, move left, decrease. Very, very simple. Great. And I also told you in the initial stages that math is something that I imagine as numbers and operators and dancing together, right? These numbers are not people who would want to just stay, I don't want to do anything. I'm just too bored of life. It is not like TED. Numbers are all very, very energetic, excited, and always wants to interact with each other. And when they actually want to interact with each other, they actually do that using certain symbols of what we basically call as operators, right? That's how I imagine all of this as. One interacts with a two, and if it basically needs to get added. It has to basically transform itself and it needs to become bigger. It uses this operator called addition, and therefore I call it added, right? If it has to basically, if 2 had to reduce itself, it interacts with a 1 with a negative sign in between or a minus sign in between, and it basically interacts and reduces its value. So it's a beautiful dance that is basically happening. And how does this dance effectively happen? It happens because of the division, multiplication, addition, and subtraction that you've already seen, the BODMAS that you've seen, the order in which you have to basically use these operators, right? So now, what is, when I basically now introduce this logic of negative numbers, positive numbers, plus and minus, I just want you to make a couple of observations. When I say 4 plus 3, what I technically mean is plus 4 plus 3, and I am adding it. That is what it basically means. When somebody writes 3 plus minus 4, what they basically mean is plus 3 plus a minus 4 or a negative 4. That is what it technically means. How do you think about this? Plus 3 effectively means I have 3 gold coins that I own, and minus 4 or negative 4 effectively means there are 4 gold coins that I owe. Right? So now when you put both of them together or you add both of them, what is the value that you have? You owed you owed 4 gold coins and you have 3 gold coins. So now how much do you owe or own? You basically owe 1 gold coin, right? And how do you write 1 gold coin? You write 1 gold coin as a negative 1. That is how you basically write the gold coin. So when somebody is talking about plus 3 plus a negative 4, what they're actually trying to communicate is how much I own, how much I owe, and how are you basically going to put them together. And in mathematics, it so happens that a lot of times this plus sign is also not written. What they end up writing is something like this, and you end up writing something like this as well. Again, plus is again becoming a default operator. If you don't write a plus, by default it is implied. It is something that you understand by default. But what is actually happening is own, owe, put them together and figure out whether you still owe or you still own, right? Great. So when people talk about 4 minus 3, what they're actually talking about is a plus 4 plus a minus 3 or a negative 3. This is what they're talking about, and this will end up with a value of 1. Think about it not as a positive number and a negative number. Just think about it as owning and owing, and you'll be able to understand the logic that we are talking about. So now you understand how all of this happens logically. Can I actually replicate this in a slightly different way? Can I replicate this on a number line? Turns out that I can do that, and to do that I have a neat little simulation that I have for you, and I have to also introduce you to my cute little friend Mr. Dragon. Just understand, let me just move to that particular simulation. Great. Now this is the simulation that I have, and there is a dragon that I wanted to introduce. Look at that dragon. It is a cute little dragon, right? So now what this dragon does is it follows a set of rules. Mathematics is all about following a set of rules. This cute little dragon that's out there, that also follows a set of rules. Do you see that this is a positive dragon? Why do I call it a positive dragon? Because this dragon is always looking at the positive side of the number line. That is where I basically hit it. So when I say plus, or when you hear the word plus, or when the dragon hears the word plus, I click it. See, the dragon is moving 1 step forward, right? Whenever there is a plus sign, the dragon basically moves 1 step forward. So now when I hit the reset button, see, it just come back to a 0. So now I hit a minus button or the negative button. What it does is it moves backward. Do you observe that the dragon has ended up with a negative 1? That is where the dragon has ended up with. Great. So now what is it that the dragon does? The dragon always looks let me just reset it. The dragon always looks in the positive direction. Why? Because it's a positive dragon. And now I can basically, whenever I have to use plus, or whenever I have to say I have to add something, it moves in the forward direction, and whenever I have to subtract something, it basically moves in the negative direction. So let me take the first question that's out there. It is saying addition, which is to move forward by a value of 5. So how do I do that? 1, 2, 3, 4 and 5. So that's where the dragon ends up with. It ends up at a value of 5. So now, if I were to say subtraction, that is, if I were to say move backward, how do I tell that? Let me reset it. Now it's back to 0. Now subtraction or a -3 is effectively -1, -2, and a -3. That is where it is. So now you understood the rules of the game. You understood how the dragon is basically playing, right? So now let's see if I can do a few operations on it. The first operation is a 4 plus 2. That's the first operation. How do you read it? It's a +4 plus a +2, right? That's how you're basically reading it. Reset it, it's back to a 0. So now +4, what should it be? +4 is 1, 2, 3, 4. It is at a value of 4. Now it is a +2. How is a +2? How does the dragon interpret a +2? 2 more pluses. Where is the dragon actually? It is at a value of 6. Great. So now you know what the value is even on the number line. Because of the dragon? No, it is because you already know the math, right? Great. Now let me again reset this value to 0. So now if the operation that you have to perform is a 4, -2. What does it basically mean? It is a +4 plus a -2. That is what it basically means, right? Four plus a -2. So it is a +4 plus a -2. How does the dragon understand a +4? 1, 2, 3, 4. That's where it is. It is on the +4 on the number line. And now it is a plus a -2. How does the dragon understand a -2? It has to walk backwards, right? -1, -2. That is, it is basically at a +3 and then it went to a +2. That is where it ended up. So what is the final value of this? It is a +2. Why? Because the dragon is standing on a +2. But otherwise as well, you understand the math behind how all of this works, right? Now, again, let me reset it. The dragon has come back to 0. So now, if I were to do the operation of a -4 plus a +2, how do you read this? It is a -4 plus a +2. -4. What should the dragon basically do? Go 4 steps backward. -1, -2, -3, -4. That is where the dragon is. Now, when it sees a +2, what does the dragon do? It basically moves 2 steps forward, right? So that is effectively -3 and -2. And what is the final value? It is a value of -2. Great. For one more operation that I have to basically do, reset to 0. Now, the operation is -4, -2. As soon as, what is running in your mind? How do you think about this? -4 plus a -2 or a -2, right? That's how you think about it. So now, if what happens to the dragon when I've reset it to 0? What happens to the dragon? As soon as it hears -4, what does it do? It moves -1, -2, -3, -4. It moved 4 steps backward. Then it is -2. What should it do? -5, -6. And we know that the value is -6. Well, it turns out that whether you're doing math, whether you're making the dragon dance, the value that turns out in mathematics is always going to be the same, right? Great. Can I extend this? Should I just do 2 numbers and then put operators in between? Well, you can extend it to any number of numbers if you would want to, right? Let's take a look at this particular operation that is there. Reset gets to 0. It sees a -3. What does it do? -1, -2, -3. Now it sees a +2. Moves in the forward direction. This is plus -2 and -1. Now it sees a 4. Now it basically gets to 0, 1, 2, 3. So what is the final value? It is a value of 3, right? Very simple. You can see how the dragon is operating as well. So now again, let me reset it to just reiterate or understand this entire thing once more. It sees a -4. Where should it be? -1, -2, -3, -4. Sees a -2 again, goes backward. -5, -6, right? Now it sees a +5. Where should it move? Forward. That is, it is basically going to be a -5, -4, -3, -2, and a -1. So what is the value going to be? It is going to be a value of -1 or -1. Very, very simple, isn't it? Great. So now, instead of actually giving you the actual values, can I give you word statements and you will be able to convert it into a positive number and a negative number? Let me take a look at it. The thing is, it is asking subtract 5 from 3. You have a 5, you have a 3, and you have to take away 5 from that. How do you represent this mathematically? Subtract 5 from 3. You have a 3 and you have to take away 5 from that. That is your mathematical statement. Like I told you, math is a short and sweet language, right? Instead of writing subtract 5 from 3, what you have written is 3 minus 5. That is how you have written it. Why? Because from 3, you had 3 coins with you. That is what it is saying. You have to take away 5 coins from the 3 coins. Now, how many coins will you have? You know that the answer is a -2, right? Why? Because you had only 3 coins and you were supposed to take away 5 coins from this. You've taken away 3 coins, you're left with a 0 and you have to take away 2 more coins. But on the negative side of the number line, therefore it is going to be a value of a -2. As far as the dragon is concerned, I reset it 0 plus 3. Well, how will the dragon basically move? It will move +1, +2, +3. It is on 3. It sees a -5. What will it do? It has to walk backward 5 steps. That will effectively be 2, 1, 0, -1 and a -2. And where does it end up? It ended up with a -2 or a -2. Great. So now can I take a look at the next question that is there? Which integer is 5 more than -5? Which integer is 5 more than -5? You have a -5. You have to find an integer that is 5 more than a -5. What does that effectively mean? So I have a -5. If I were to talk about a -5, what should the dragon basically be? If I reset it, now it's come back to 0. Where should the dragon effectively be at -5? -1, -2, -3, -4, -5. It has moved 5 steps back and it is at -5 as you can see out here. Now, I have to find an integer which is 5 more than -5, which effectively means the dragon has to move 5 steps in the positive direction. So now, how will I make it move? 1, 2, 3, 4, 5. Where did it end up with? You see that it has ended up with a 0. So what is the question basically trying to tell you? It is asking you -5 plus 5 is what is the value, and we found out that the value was 0. How did you understand this? It said it has to be 5 more than a -5. -5, the dragon was at -5. I had to add 5 to it to end up with a 0 because it had to be 5 more than the -5. Therefore, the final answer or the final value is a 0, right? Okay, now let's take a look at the next question that's out there. Now I'm going to use the dragon. You already understand the logic of the dragon. Now I'm just going to use the number line and let's understand how to go about. How many integers are there between a -6 and a 2, right? That's the question. How many integers are there between a -6 and a 2? So now there is this particular part of the number line. How many integers are there? So there is 1, 2, 3, 4, 5, 6. If you were to basically say 2 is not included, then the value is 1, 2, 3, 4, 5, 6. That's how you basically start counting. So why did I ask you this question? Because there are integers between two numbers as well. And the number of integers, you just draw the number line and you will be able to count the number of integers that are there in between. Very, very simple math, not complicated at all. So two more observations that I want you to do before we end this particular class, right? So now, if I were to basically add in one particular way, that is, if I were to take 4 and add a 2 to it, let me just do it on the number line. I was at a 0, I ended up with a 4. So now let me just change the color out here. I ended up with a 4, and now I add another 2, I end up with a 6, right? This is one way Great. And the final answer is 6. But if I were to do it in a slightly different order, that is, I take a 2 and then add a 4. Instead of taking a 4 first and then adding a 2, if I were to take a 2 and then add a 4, let's see if the value is going to be the same. I've used a slightly different color. When I take a 2, this is where it is going to end up with. Now, when I add a 4, that is 1, 2, 3, and a 4. When I add a 4, this is where it will end up with. You observe that both of it is actually giving you a value of 6 itself. That is, the observation that I wanted you to make is whenever you're adding, whether you're adding 4 and 2, or when you basically change it and add a 2 and a 4, the order in which you're going to basically add it does not matter whenever addition of the number is concerned. And the second observation that I want you to basically do is, if I wanted this particular command, that is, you have to end up with 0, irrespective of any number that you are on the number line. Let's say if I was on a 4, let's say I was basically standing here, and I had to give you an instruction of you have to always end up with a 0. What is the number that you will basically add or subtract such that you always end up with a 0, right? This notion of whenever you are always end up with a 0 when you're adding numbers, that notion is what we basically call as an additive inverse. Very, very important notion. Just like 0 was a notion, just like negative numbers were a notion, additive inverse is also a notion that I basically want you to take away. What do I mean? I can be anywhere on the number line, and if the command is go to 0, what should the number be that I should add such that I end up with a 0? If I'm at 4, what number do I have to add to 4 to get a 0? Very, very simple. I have to add a negative 4, right? Why? If I were at 4, or just imagine the dragon being at 4, how will it be able to get back to 0? It has to walk back 4 steps, right? When it has to walk back, what is it? It has to be a negative number. So therefore, it has to walk back 4 steps. That is, a negative 4 needs to get added to a 4 to end up with a 0. In the same way, if your initial value is a minus negative 3. If the initial value is a negative 3, that is how the dragon is at this point in time. To get back to a 0, in which direction should it move? It should move in the forward direction, right? If it has to move in the forward direction, it has to be a positive number, and therefore I have to add a plus 3 to get to a 0. So what is the observation? When you have a 4, the same value is basically retained. You just need to change the sign for you to actually go to 0. If the command is go to 0, all that you have to do is to change the sign and you will end up with a 0. And when you do this, when you change the sign of the particular number such that the value is kept the same, the operation that you are doing is what we basically call as additive inverse. That is another notion that is something that I would want you to take away with. So the number which makes the sum 0 is what we basically call as additive inverse. Great. So now, what are the things that we learned today? We learned about Ted, of course, and his story. And through that story, what we learned was that we have natural numbers. These are numbers that are positive, and these are numbers that you can basically count. When you have nothing, you basically call it a 0. And then when you owe something, that is when you are on the negative side of the number line, you have negative numbers, right? This is something that we basically understood. So these are positive numbers, 0, and negative numbers, and you put them all together. The family of numbers that you basically form is called the integers. So now, whenever I have to add a number on the number line, I have to move right or move forward as far as the dragon is concerned. And whenever I have to subtract a number, I move left or move backward as far as the dragon is concerned, right? And what is an additive inverse? What is the notion of an additive inverse? Additive inverse is effectively the command to go back to 0. So if I were at plus 6, I have to add a negative 6 to end up at 0. If I were at a negative 6, I have to add plus 6 to get back to 0. What do I have to do? I just have to change the signs so that I'm able to obey the command go back to 0. Right? That is also something that you have basically learned. And as far as addition is concerned, the order in which you're adding, whether you take a 4 and a 2 and add them up as 4 plus 2, or I take a 2 and a 4 and I add them as 2 plus 4, the answer is always going to be 6. That effectively means the order in which you're trying to add these numbers don't matter. Right? These are the 4 takeaways that I wanted you to have as far as this class is concerned. And I thoroughly enjoyed helping you understand this concept of a negative number as well as how to add and subtract on the number line. Something that is very, very simple, but the notion of this is something that you will continue to use as you keep growing higher and as you become stronger and stronger in maths. Right? So as far as today's class is concerned, I thoroughly enjoyed it. I hope you enjoyed this class as well. Till next time, thank you. Bye bye.